Welcome to our lesson today. We're going to be talking about how to write polynomials given roots. In a previous lesson, you may have learned how to get the roots, real and complex, from a polynomial function. Today, we're going to work the other way, and we're going to build those functions given the roots. Let's first review a little bit of how the factored form of a polynomial relates to the zeros. So this question simply asks, find the zeros of the function, state the multiplicity. Let's talk about what multiplicity is. Multiplicity is how many times you see that zero occur. And in this case, it's actually just the exponents. So whatever the exponent is, that's going to be your multiplicity. So let's just basically set each factor equal to 0. So we'll start with the x squared. Now we don't really need to have the square on there. You can say x squared equals 0, but really just x is going to equal 0 in that situation. Now its multiplicity is going to be 2. Because of that square, right? So that's going to be that one right there. X minus 7 to the third power. I'm not going to write the third power, but again, we're going to set that equal to 0. We're going to add the 7 to both sides. And of course, you're going to get x equals positive 7. Its multiplicity is going to be 3. The 2x minus 7, set that equal to 0 as well. Again, ignore the 6. Now this one, we're going to want to add the 7 to both sides. So that's going to give you 7 on the right side, set equal to 2x divided by 2. And you're going to get 7 over 2. And we can leave that as a fraction. You can say 3.5 if you want to. And that multiplicity is going to be 6 because of that exponent. So multiplicity is going to be 6. And finally, for the x plus 3, that's going to be -3. And the zeros and the factors are always going to have opposite signs. So you're really just going to minus that 3 from both sides, and you're going to get -3. It does not have a number for the exponent, so that's kind of like a hidden 1 there. You can say multiplicity of 1 if you want. But now we got all of our zeros, all of our real zeros, and here they are. X equals 0 with a multiplicity of 2. X equals 7, multiplicity of 3. X equals 7 divided by 2, which is 3.5 with a multiplicity of 6, and x equals -3. You don't have to say multiplicity of 1, but it's not going to hurt. So I'll kind of circle all 4 of those. One real quick thing, you may be tempted to graph something like this because you've graphed these before. So if you graph this in Desmos, of course, you're going to see those zeros, -3, 0, 3.5 is the 7 divided by 2, and 7. And those are your real zeros. But it's kind of hard to tell the multiplicities from a graph. So you really need to just look at the exponents when it's in factored form to get those. Awesome, guys. So make sure you write that down. And then I want you to try the next example. Let me clear these annotations. So I'm going to pause the video. And you're going to try this on your own. Pause the video, try this on your own. You can check my solutions in just a minute. Okay, guys, I've worked this out. You can see the 4 zeros at 0 with a multiplicity of 5, 9 multiplicity of 2, -5 over 3 with a multiplicity of 2, and -2 with a multiplicity of 1. Remember, that's a 1 there. Now, hopefully that checks out with you. The next video, we'll talk about now actually writing the polynomials given the zeros. So tune in for the next one.